Is that no?
Right, okay, binomial distribution. So, we're flying through this stuff, and I'm really sorry if you're like, what? Too much? It will all come out in the wash, I'm sure. So, essential elements of binomial distribution. There are a fixed number of trials. Okay, so they will say that something is happening blah blah amount of times. Each trial only has two possible outcomes: success or failure. Okay, so you roll a 6 or you don't roll a 6. You win the lottery, you don't win the lottery. Those are the kinds of things that we're looking at. Okay, the probability of success is going to be constant. So they will tell you that something is constant from trial to trial. And the trials are independent of each other. So if they do something successfully one time, it doesn't affect any subsequent trial. No, event. Shut up, you know what I'm talking about. It doesn't matter if they win or lose for the next time. Oh my god.
Just over and fight to shut up.
Huh? I told myself to shut up.
He's gonna send that call, now I don't have any evidence. Yeah, I do. Oh, yeah, I'm drinking.
Right, so the outcomes of a binomial experiment and the corresponding probabilities are called binomial distribution. So binomial distribution describes behavior of discrete variable big X if the conditions above apply. So we define it with two parameters. N is the number of trials and P is the probability of success. So they will tell you this information in the question. You will often see something fancy a bit like this. Ooh, shush now. So X, and they do a little squiggle. B stands for binomial, and then they will write the numbers in there potentially, or the N and the P, okay? And that's indicating that it's binomially distributed. So if a question has just success or failure, then you're going to be using this method. So you might look at a question and think, oh, this is a probability question, but more specifically, it's a binomial question, okay? This looks really complicated. Stress not, okay? So if we want, oh, this guy's way too sensitive. So for our X value to equal a specific number, it would be NCR. Where have we seen NCR before?
Yeah.
Yes, so and that's the link to this. Okay, so that's, remember we had to find out how we find that bad boy on our calcs? And P is to the power R, and then 1 minus P. Why do you think it's 1 minus P?
Isn't it like
Hang on a minute. Several people were saying things at different times. Sarah, what did you say? Yeah, so what did P represent? Probability of success. In this question, it stood for probability of success, yes? Mm-hmm. Well, what do you think? What's 1 minus P going to be then?
Oh, because probability is out of 1, right?
Yes.
And then
so that would be the probability of not successful, yes? Are we all following that, yeah? So that's why it's P and 1 minus P. So this is to the power R, ooh, shush now, and this is to the power N minus R. Lovely jubbly. Remember, get given this in your formula sheets if it's on the non-cap paper. Often, rather than see the 1 minus P, they may write Q. Okay, so they may just call that the probability of failure as Q. Right, so a fair coin is tossed 10 times. Find the probability that 6 heads will occur. Right, we would write P X equals, what do you think we're going to write? From the question? 6. Is equal to, I know, Shelbs, I knew. Oh, and maybe I should have established this first. Sorry. What's N in this question? 10. What's P in this question? I haven't told you, but you know this.
4.
What did P stand for?
That's
The probability of successful. What's the probability of getting ahead?
5 or 10.
A half, yes?
I know 5 or 10. Yeah. Simplified. Oh, we have to. I thought we didn't have to simplify it.
You don't have to, but it's unusual to say.
There's 5 out of 10. There's 2 sides. 2 sides of the point, and 1 side of the point of the head.
So 0. Oh, that looks like a 6.
6.
Yes.
You said that Q is the probability of not success?
Yes.
Oh.
Here.
And that's the same as 1 minus E.
Yes. Up here it says it's written out there. Excuse me. So N is 10, P is that. So Q would be what?
0.5.
Yeah, 0.5 or a half as well. Now this is not normal, okay? So don't think that because they're always going to be the same. They're only the same because we've got 2 different options. The probability of getting ahead is half. The probability of getting a tail or not ahead is also a half, yes? So if it was catching a fish when we go fishing is 0.6 and the failure would be 0.4. Okay, so just always remember this value here will always be 1 minus P, whatever P was. You right with that, Jen, now?
Sorry?
You right with that?
Yeah. I was like, what?
All right, so now we can actually start filling this in. I should have done that first, sorry. So we've got 10C. What's our R going to be? We filled it in already.
Oh, 6.
Nice. Again, shelves. 1/2 or 0.5 to the power what?
To the power 6.
Nice. Good one, Joshna.
Thank you.
A half to the power of, which is, okay, speedy. And then we just work that out. Just work it out.
How do you work such a thing out?
Just work it out. Look on my couch.
I had my calculator too.
Oh my goody aunt. Something is going on. She didn't come to the maths to have a lunch, but she's doing well in the lesson. Okay, so your couch still in my room.
Actually, I have 2 calculators, so I'm ahead.
You just put C as like the actual calculator.
So remember on the cat that you do the NC, you need to go to that probability bit. You have math and then across to probability.
Okay.
And then you'll see the NCR. Let's pull. All right, so there we go. We've got 0.0205.
Is
So
there a unit for that or no?
no, so it's probability. So and that's what I was just going to say actually. So we're tossing a coin 10 times. What's the probability that 6 heads will? So having 6 heads in just 10 options, is that a big or a small probability? Small. It's not that likely. Yes. I mean, and we know that that's kind of true because we would expect half and half. Yes. So, but that's how you would work it out. Are we good with that?
Mm-hmm.
Next example L. Example L.
Example A? Example A?
I know, I do. Look
I did a little spin.
Mm-hmm. I do get it. It's
No.
a ballet spin.
So, A. So we've got a probability that a particular page on a maths book contains a misprint is 0.2. Find the probability that 12 pages, that of 12 pages in the book, 4 of them contain a misprint. So, how am I going to start this off?
We're gonna do our N's and our...
P big X.
Wait, can we do our N's and P's?
Oh, sure, totes my goats. Yeah.
Because Q equals 1 take away P, does that mean that P equals 1 take away P? Or the other
Yes.
way? Yeah, I was just so right.
Yes. Right, okay, so let's establish our values. So N in this case is 12. What else do we need to know? P?
0.2.
Yep. So Q would be nice. And in this, for part A, the value of R is
4.
4. Nice. Okay, so there's lots of Do we see now why the R is 4 for this question? So we write our big fancy thing. Oh, I forget, the P's outside the bracket, isn't it? Big X equals 4. Oh, no, I wrote R. Bless my little heart. And equals. Tell me what to write.
Equals. Equals 12C 4. And then it's 1 second. And then it's 0.2
To the power.
4 to the power 4. And then it's 0.8.
To the power.
So 12 minus 4.
Which
To the
is.
power 8.
Okay. And we're going to chuck that in our counts.
Wait.
All right. So thanks, Shelby, for that answer.
You're welcome. Oh, that's the whole answer. And they say on the feet.
So yeah, I just did the total answer. Again, the probability of having a misprint is 0.2 of 12 pages. 4 of them having a misprint, it's a small probability. Okay. The only reason I'm saying that is just to get you to think about what you're actually finding. You're finding the probability that out of 12 pages, 4 of those pages have a misprint. Now, this, you right?
Yeah.
So, this next one, fewer than 2 of them contain a misprint. Right. So this is where it's a little bit more work, because fewer than 2 means that we have to find the probability when X is 0
Or 1.
when X is 1. Okay? So we're going to have to do both of those 2, and then what we're going to do with those numbers? Add them together. Yeah. I'm not going to do my N, P, and Q for all of them. Is that all right?
Yeah.
It's just because of my R is the only thing that's changed. So we've got 12C0, 0.2 to the power 0, 0.8 to the power 12. What I might do here is, because my final answer needs to be to 3 significant figures, is I might keep a couple of extra digits on these before I add them, because sometimes that can change it a little bit. So what should this bad boy have been if we keep a few extra? 6, 8, 7, 1, 9. Okay, that'll do. And then the 206, was it 206 still?
Yeah, 158.
Oh, that doesn't look like a 5. Anyway, so just be aware that sometimes it's useful to keep a few extra digits. And so the total probability is going to be those 2 added together. Did you put a 0 in here?
Nope.
I knew. Yeah. 2, 7,
5.
5.
And then 0.2.
This bit here tells us how we can use our GDC. So rather than chuck in all of those numbers into the formulae, we can actually just put the information into the counts. So if you want something equal to a probability, then you follow these instructions. You're going to use this binomial PDF, okay? So PDF, Number of trials, so it literally, number of trials, blip, 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 tells you everything you need to do. If you want a range of values, so if you want less than something or less than or equal to something, then you use CDF, okay? Now, X is the upper limit, okay? So if you've got X is less than 4, I don't like it when it draws and I don't want it to. If X is less than 4, then your upper limit is going to be 3. You'll see that? Mm-hmm. Yes. If it was less than or equal to 3, then your upper limit is going to be 3. So just be careful what the symbol is, okay? Now, if one of your questions is greater than, then you can find the CDF for the lower limit and then subtract it from 1. So if it says find the probability that more than so-and-so, find the bit less than it and subtract from 1. Does that make sense? Yeah? So, X is binomially distributed with 6 trials and a probability of success is 1/5 at each attempt. What's the probability of exactly 4 successes? So this time we'll use those calc rule instructions. So we would write oh no, let's establish our values. Because I like doing that. That's a good option, good option, good option. So for A, N is 6. P is 1/5. Q is 4/5. And for this question, R is 4. So we're finding Px equal to 4. Oh God, I keep doing it. Just keep writing R. And so let's just chuck that bad boy in the calc. I can't bother to bring up my calc, sorry. So for B, what are we going to do for B? So P, big P, X, and we want at least 1 success.
We do the CDF one, right?
Well, yeah, well, actually, let's establish what at least 1 success means. It's going to be greater than or equal to 1, yes?
Yeah.
Now, what did we say about greater than or equal to
You
things?
did the one, you just did the last thing.
You do the bit that we don't want. So the only one we don't want is what?
0.
When X is 0. So actually for this, we're going to do 1 subtract that. Does that make sense? So I'm going to let you do that. All right, so there we get those answers there. Okay. So last one for this little bit. It says we want 3 or fewer. So C would be big P, X, and what we're going to write here? 3 or fewer.
Less than or equal to 3.
Less than or equal to 3. So now we can stick in the calc. What's our limit? We're going to use the P or the C?
C.
The C. And we're going to use 3 as our value, yes?
Mm-hmm.